Welcome back to the channel. I hope you all are doing well. This is Chetan Kumar from iLearn Academy. Let's learn to learn and learn to earn. So, we were discussing about BCA, data structure, lab manual of second semester as per SEB syllabus. Dear students, today we are learning about program number 6 and it is related to the working mechanism of your CLL, and that CLL is your type of queue, and that type of queue is your circular queue. And let us move on to the actual program. This is your actual program, and the program problem statement is writing a program to simulate the working of circular queue using another kind of data structure, that is your array. So always, as I said earlier, while you are writing any of the C program, so you have to start from a standard library, and here we are using one of the common standard library, that is your stdio.h, that is standard input output dot header file, and followed by we are using one of the preprocessor directives, that is hash define max, that is up to 5. So wherever the max variable is, there it will substitute the value, that is 5. So we are using those value as the limit, and followed by we are creating one of the structure for our circular type of queue, and within the block we are initializing or else we are declaring int type of array, within the subscript the variable, that is max. Within this max, these 5 will going to substitute, and our second declaration of the variables are front and rear, which is of type integer. And why we need front as well as rear? Just to represent insertion operation as well as your deletion operation. And as I said earlier, insertion will be takes place within your rear end of your queue, and your deletion operation will be takes place within the front end of your circular queue. So after the creation of those structure, your compiler will dive onto the main function to start the execution, and within the block again we are just using the same circular queue followed by the lowercase q, and this lowercase q will act as a object, okay, for every initialization or else calling function. This works as what? The object, or else any kind of object variable as well. So followed by we are again calling one of the method, and that method name is what? Initialize q, and it is accepting only one number of parameter, and that parameter name is what? The q as a object with ampersand symbol, and that ampersand symbol will be known as what? Address of operation, since here also we are demonstrating the concept of pointer. And within the next line we are doing our first operation, and that operation is what? Inserting our required values. And as we already discussed in the last program, for the insertion operation within the term of a queue, we call it as Enqueue operation. But how many number of elements we are inserting? So 1, 2, 3, 4, 5. Our intention is to insert 5 quantity of elements by using the two parameters. The first parameter is your q as a object, followed by various actual elements, and those actual elements are: first element is 10, second is 20, 30, 40 and 50. And after insertion operation by using a Enqueue method, it's very essential to display all the inserted element. For that, we also use a display named method with what? The one of the parameter, and the same parameters are our q, lowercase q, that is as a object. And next, your compiler will navigate towards where the actual declaration of these method. So let us jump on to that part. So the first called method is which one? The initialize queue, and it is accepting several parameters. The first parameter is which one? The circular queue, which is of a structure by using the struct keyword, and it is demonstrating the pointer by using the asterisk symbol, followed by the queue as what? As a object variable. And within the block we are utilizing those two variables just to create one queue named structure. Okay, before inserting, before deletion operation, so we have to create the structure first. For that, we are utilizing what? Queue of front as well as queue of rear is equal to -1. -1 refers to what? Your queue type of data structure is empty, since we have created just now. And the other way to write these lines of logic is q of front is equal to rear is equal to -1. Okay, we can follow these kind of logic, but both are same. Okay, after creation of a structure, but before doing insertion, okay, we need to check for the condition. That condition is what? Is full. As we discussed in earlier program, is full condition is also known as overflow scenario. So before insertion operation, we have to check whether your queue container is full or not. If it is full, we can't proceed further. Okay, we can't insert any of the new element inside the queue. Okay, due to this reason, before that we have to ensure whether there is a place left or not. For ensuring that one, we are using one of the major operation, and that major operation is the modulus operator. By using that one, we can ensure whether there is a remaining space is available or not. So just to ensure, we need to start the return type is integer, and the actual method name is full, followed by it is also accepting several number of parameter. The first parameter is a struct type of circular queue as a structure name, and it is following the asterisk, the pointer perspective, followed by again the lowercase q, just to use it as an object variable. And within the block, we can return the scenario as if it is true, because we are asking the container, the queue, whether it is full or not. By default, it will be, the result will be returned in the format of true or false, since it is the type of boolean. Okay, whatever the function or else method which starts with is, then it will be a type of boolean. When it comes to boolean, it always results in a two perspective, that is a true or false. If it is true, the pointer will come towards this logic. Okay, within that logic, what we are trying to ensure? So q of rear. Why the rear? Because since we are utilizing the insertion operation, and already we know in which end the insertion operation will be takes place within the rear end itself. So rare plus 1 means before insertion it has to be incremented. Okay, and we are operating based on the modulus just to prove or just to validate, just to check whether there is a remaining space left or not, whether it is reaching the maximum perspective or not, and followed by is equal to q of front. So within the strategy of a circular queue, it is very essential. If your queue is full, again it is taking the next round. It means what? The rail is leading towards the other end, that is the front. This is how we can check the dead end of the first cycle. Just assume we have total 5 as a maximum block within the queue data structure as the memory. Okay, at the time, if your queue is full, how we can prove that? Just assume 4 plus 1. Okay, just we are checking to increment. 4 plus 1, that means how much? The 5. 5 modulus, if the pointer is already reached that 5. 5 modulus of 5, how much? The remainder is 0. The remainder is 0 means what? There is no any remaining space left. And again, we are proving what? The rear end again leading towards the first cycle, and within the last end, it is reaching the front end again. This is how we can check the easeful perspective. And our next condition as well as the scenario while we are performing deletion operation is which one? That is your is empty, and that is also known as a underflow condition. Okay, before deletion, if you want to ensure there is at least the minimum element present to delete or not. Okay, just to make ensure that one they have a is empty, and it is also accepting the same type of parameter. And within the block we are trying to return this kind of logic whenever the scenario, that is queue of front. Why the front? Because always within the queue the deletion operations will be takes place within the front end itself. And if it is equal to minus 1 means what? The condition of it is the container, the queue is empty. Okay, minus 1 means what? The negative perspective of a index. Okay, it is also a meaning of the value itself not reached the 0th index. It means what? There is no any value left to place our delete operation. So, dear students, after ensuring the above conditions, now it's time to insert our elements by using the actual method declaration, and the method is Enqueue, and it is accepting certain parameter again, that is two number of parameters. The first is which one? The object q variable. Okay, and previously the circular queue as we discussed already, and followed by int value. While we are calling that method, how we were used? So ampersand q comma, we have introduced the several number of elements one by one after the other. Okay, for every those numbers, these logic has to be executed. So we can check before insertion, we need to ensure this condition, that is full, as we saw already, that is before. Within that, if the scenario is full, that means your container is full, there is no any place left to introduce our new element. At that time we can acknowledge with the printf statement as what? Q is full, cannot enqueue, and within the place of percentage t, the actual value will be substituted. And if not, if your queue container is not empty, your pointer will be preceded with the else part. Within the else part, we have one of the conditional statement, and that conditional statement is to check whether any kind of element is present or not. So based on that, we have a queue of front is equal to -1 scenario. -1 scenario means we are starting our inserting operation from the beginning. That is, before inserting, your pointer index was in the place of -1. If we introduce the new element, it will be allocated within the index number 0. Okay. For that insurance, we are doing this condition. So that is the index number 0. Okay. In this place, our first element will be inserted. To do that insertion operation, these two lines of logic will be essential. Okay, within this line, what we are doing? Queue of rear. Why the rear? Again, within the rear end itself, we will perform the enqueue operation. And after that, equal to queue of rear plus 1. Again, -1 2, we have incremented by 1, that is negative to positive to accept our first element, that is within the index of 0. For every element, our rear index should be incremented. At most, it can reach up to the max. And how much we have fixed? The max. Max is up to 5. And based on the remaining index, or as based on the remaining places within the memory, it can accept at most number of elements. And how we can introduce our actual elements within this line. Okay, queue of ARR, that is the array. Within the subscript, queue of array, this is the actual index, where is the actual pointer is inside the array memory as queue you are performing. And within that is equal to value. This is where we will introduce our actual value. After introduction of that value, we have to acknowledge to the end user, to the programmer, as what? Enqueued %d. Okay, within this place, your value, actual value will be substituted. Okay, for every n number of elements, these are all the steps. Okay, it has to be executed until we reach the limit of maximum number of elements inside the queue container. So, after doing any kind of updation, that can be any kind of insertion or deletion, it is very essential to display those elements. To display that, we have a method, and that method name is what? The display. And it is also accepting the same parameter, that is object variable lowercase q. Within the block of display named method, we have the first condition itself to check whether there is minimum element present to display or to print or not. Okay, for that insurance or for that validation, we are using the is empty function. Okay, if that is scenario becomes true, at that time we can acknowledge it as what? Queue is empty, or else based on the technical word we can acknowledge it as what? Queue underflow. It is the scenario there is no any element present within your circular queue to be displayed. Okay, for that we can use this kind of statement. And if it is not becomes true, okay, at that time the pointer will flow towards your else part. Okay, when the pointer will flow towards else part, whenever there is a certain number of elements present within your circular queue. Okay, at that time we can just print one of the headline as your acknowledgement statement, that is queue elements. Okay, queue elements, and followed by int I is equal to queue of front, because whenever we want to print the elements, we have to introduce one of the iterative variable. Okay, like that we are initializing our I, and that I is dependent on what? Queue of your front end. From the front end we can start our traversal operation. Why we are performing traversal operation? Because as I said in earlier programs, whenever we want to print the elements, we have to traverse. Whenever we have to traverse the element, we have to use any kind of looping construct. Okay, what kind of looping construct we are using now? That is while type. And why we are using the while type of looping construct? Whenever we don't know the range, okay, at that time we will use the while, and within that it is accepting one of the condition, that is I should not be equal to q of rare. Okay, because it is ensuring, okay, that is the case of what? I is not equal to in the place of where your front end is. Okay, when will be that scenario will arises, encounters whenever there is no any place left, or else whenever your queue is full. Okay, vice versa. At that scenario we will use this condition, okay, just to validate. Within that block we are using what? One of the printf statement, just to print the elements percentage d. Within that we are printing our current visited value, that is element q of array of I. Wherever the I, that will be reflected onto the screen one by one. Okay, not within a single instance. Okay, and after that, after every kind of visiting element, the iterative element has to be proceeded with the further available elements. For that we have to increment our iterative variable by 1. For that we are using I is equal to I plus 1. But how long it can be incremented? Until it reaches our max, which is the 5 as the limit. Okay, up to that it have the boundary as a range. Okay, we need to use that percentage always. Okay, because since there is a remaining element itself, okay, we can allot the elements within the specific index, that means within the range. If not, we can use it as what? The maximum followed by front, which is facing rear, is following towards the front, which is of one cycle. Okay, and further we are again printing as after every element has been inserted completely. If you want to display the elements, at that time percentage d. Within that queue of array, within that the queue of array. Okay, we are using two concepts. We are diving onto the array. Within that array we are utilizing our rare perspective, that is the concept of queue. Okay, and this queue is implemented based on your array. Okay, we are just migrating to concept. The characteristics is your queue, but the type of memory is your array, as a contiguous, continuous, linear, sequential memory. Okay, this is how we can display our all the available elements one by one, and finally all within a single instance by using this line. Yes, dear students, till now we have seen the operations of Enqueue. Okay, and as well as we have printed those elements as well. Okay, after doing so, the next operation is to delete the elements one by one. For that operation, as per the queue, we have the dequeue as a technical word within the queue operation. And At the same time, we are acknowledging the statement as well as we are calling the method. Okay, simultaneously within the same line we are doing. Okay, one is acknowledgement, and within that we are introducing one of the method called to be deleted, and that method name is dequeue, and it is accepting one of the parameter, that is by referencing address of operator followed by object variable, that is lowercase q. But how many elements you are trying to delete? Number 1, number 2, okay, and followed by number 3, number 4, okay, as a insertion. After deleting the two values, after that again you are performing a enqueue of two quantities, that is further elements which is to be added, that is 60 and 70. But before that, to delete these two elements, we have to navigate towards the actual method declaration of a dequeue. Let's move on to that part. Yes, this is the part of actual declaration of your dequeue, and it is accepting the same, the queue as a object variable, and within that again we have to verify is there any kind of element to delete or not. Okay, just by utilizing the is empty function. If it is becoming a true, at that time we can acknowledge it as what? Queue underflow, or else queue is empty, we can't proceed further of a deletion operation. And at the same time we can return with the -1. -1 means what? The unsuccessful operation. Okay, that is the first logic. And if the container is storing or else placing any kind of element, at that time it will lead towards the else part. Within that else part, we can proceed the logic based on the deletion operation. Within that, the first scenario is to introduce one of the variable which is of type integer, that is value, because we need to specify the value which is to be deleted from the front end. For that declaration, we are using the initialization part as a queue of array. We are entering into the array, followed by within the subscript, by following characteristics of the queue, we are entering the queue of front end to delete that specified value as an element. Followed by we are checking the condition whether there is at least one element present or not. If the scenario is only one element is present, at that time we can represent it as queue of front is equal to -1, as well as rail is equal to also a -1. If both are within the negative aspect, okay, at that time your value is only a 1 element in the queue. Okay, because we are checking for equality between front and rail. Okay, and followed by within the else part, again we are utilizing the queue of front. Okay, this logic will be useful for deletion of the element. Okay, at that time your front should be incremented. Okay, while you are inserting, the rail will get incremented by 1. While you are deleting, the front will get incremented. At most it can reach up to max as a limit. After that we need to return that deleted value. Like this we can dequeue n number of elements one by one, but within this we are trying to delete only 2 elements. For those elements it has to be executed twice to delete 2 numbers. Okay, after the deletion operation has been successfully executed, at the last what we can do, we can display the updated circular queue after overall the operation, and finally we can return back to the main function, that is within the console. Okay, with the output. Now let us discuss about the output. Yes. Dear students, this is your sixth program's output to Enqueue as well as a Dequeue. So initially we are trying to introduce five, 1, 2, 3, 4, 5, 5 number of elements, followed by, okay, that is the overall within a single instance as the series of element as the output, okay, till this. And followed by we have performed two deletion operation by using the Dequeue, that is the 10 and 20. Okay, since we need to know FIFO principle, first in, first out, based on the queue strategy. Followed by what we have done, again we have inserted two more values to the same queue elements after two deletion operation. After overall the updation, what is your last finalized circular queue elements? This is the one. Queue elements 30, 40, 50, 60, 70. Like this, you can change your required values to perform these kind of insertion and deletion operation. I hope you all have understood today's concept. If you find topics interesting, do like, share, and if you have any of the questions, just comment me below. Thank you.